Welcome back to the channel, everyone. Today we are going to solve the next problem in our DSA series, that is finding the maximum and minimum element in an array. At the first glance, you might think that this problem is incredibly easy. You will just traverse through a for loop and find that element. But here is a catch. In a real tech interview, solving this problem is not enough. You have to optimize the problem. So today I'm going to show you the brute force way, the better way, and the highly optimal way, that is pairwise approach that will completely blow the interviewer's mind. Let's jump into the notebook and see what is the problem statement. So the problem statement says that we have to solve this array and find the maximum and minimum element from this array. So we have to simply traverse this array and find the maximum and the minimum from it, and we have to return this as answer. So the minimum is 1 and the maximum is 8. So we have to return this as answer. So first we are going to use one answer variable and going to store this value inside this answer. So declare one vector array that name is answer. And after that, in brute force we can think of like that we can directly use one STL function, that is sort, and sort will make your array sorted. So after sorting, this array look like this: 1, 3, 4, 5, 6 and 8. And after sorting this array, the first element represent the minimum element and the last element represent the maximum element. So we have to push this minimum element and the maximum element inside this answer, and we have to return the answer. So the pseudocode for this is we have to declare one answer array, and after that we have to sort this array by using STL function sort. And after sorting this array, we have to simply push the minimum and the maximum element from this sorted array. We don't have to create another array because this sort function directly take the reference of the actual array and sort that array. So the first element of that array represent the minimum element, and we have to push this inside the answer, that is the minimum element, and the last element, that is n minus 1, that is maximum. So we have to simply push this also inside the answer, and our answer become 1 comma 8, and we have to return this answer. So this is the brute force way via which we can solve this problem. And for this, the time complexity for this problem is, because here we are going to use STL function. So the time complexity for this problem is n log n, because STL function time complexity is n log n, and apart from that, we are not using any for loop or while loop or any loop. And the space complexity is 1 because we are not using any extra space. So this is the brute force way. Now we are going to solve this problem via better way. So we have seen the brute force way to solve this problem. Now we are going to solve this problem in a better way, that is linear search algorithm, in which we are going to assign the first index as the maximum and the minimum, and we are going to compare this maximum and the minimum with the rest of the array element and update the maximum and the minimum. And at last, we have to simply return the maximum and the minimum, that is answer for this problem. So currently maximum is 1 because we have already initialized that array 0 is the maximum element and the minimum element. So minimum element is also 1. Now for loop traverse from index 1 till index 5. So the first index value is 4. We have to compare this 4 with maximum and minimum and update the maximum and minimum. Again, move I from 1 to index 2 and the value is 3. We have to compare this 3 with the maximum and compare with this minimum. No need to update here because 4 is already greater than 3 and 1 is already less than 3. Now index move from 2 to 3 and the value is 5. Compare this 5 with the maximum and minimum. So maximum is updated with 5. Again move index from I equal to 3 to 4 and the value is 8. Update the maximum. Again move index from I equal to 4 to 5. The value is 6. Again compare this 6 with the maximum and the minimum. No need to worry about this because 6 is already less than 8 and 1 is already less than 6. So from here we can see that the minimum is 1 and the maximum is 8. So we have to simply return this 1 comma 8 as the answer. There is one edge case, like let's suppose we have only one element in an array. So we have to simply return this as the minimum element and this as the maximum element because there is only one element, so no maximum, no minimum. So this one is the maximum and this one is the minimum. So we have to simply return 1 comma 1 as the answer. So we are going to write the pseudocode for this, like if n equal to 1, like if there is only one element, then we have to simply return array 0 comma 0. And in other case, we have to declare two variable. One is minimum value and another one is maximum value. And both the values are initialized with the first index value. And now we have to traverse a for loop from index equal to 1 because we have already stored the first index as the maximum and minimum. Now we have to compare this with the next element till the last element of this array. And if the array of that index is less than the minimum, then we have to update the minimum value. So the minimum value become array I and do the same with the maximum. Like if array of I is greater than the maximum value, then we have to update the maximum value with the array of I. And at last, we have to simply return this maximum and the minimum. And this is the better way to solve this problem. Now we are going to move forward to the optimal way by which we are going to solve this problem. Here we are only using one for loop. So the time complexity for this problem is big O of n. And the space complexity for this problem is big O of 1 because we are not using any extra space here. So now we are going to solve this problem in a optimal way, that is pairwise approach. In the previous approach, we are going to traverse the whole array. But in this pairwise approach, we reduce down the number of instruction because we are going to pick up one pair and compare and find the maximum and the minimum value. So here one is the minimum and four is the maximum. And our for loop is starting from index 2 and every time index is updated by index plus 2 because from here like you can see that this one is the one pair and again you move to 4 and you got another one pair. So first, we have to find that which one is maximum and minimum in the first pair, that is 1 comma 4. So 4 is greater than 1. So 4 is stored in maxi and 1 is stored in mini. Now our for loop is starting from index equal to 2 and index is moved till index is less than array size minus 1 because we've only moved till the index 4 and we found the pair that is 8 comma 6. So no need to move till 5. So our for loop is run till n minus 1. And every time we have to update I via I plus equal to 2. So our first maximum and mini is updated. Now we are going to index equal to 2 and we found the element 3 and the next element is 5. Now compare these two elements and find which one is maximum and which one is minimum. So here after comparing we found that 5 is greater than 3. So update 3 as minimum element and 5 as maximum element. And compare this maximum element with the maxi and compare this minimum element with the mini. And update the maximum and minimum. So maximum is updated by 5 and minimum is still 1 because it is less than 3. Now our index moved from I equal to 2 to I equal to 4 because every time we have to skip one step and I equal to plus 2. So our index become I equal to 4 and now compare 8 comma 6. So after comparison, you got that 8 is greater than 6. So 8 is stored in max element and 6 is stored in min element. Now compare 8 with the maxi. Now maxi become 8 and we have to compare mini element with the minimum. That is already minimum. 1 is less than 6. So no need to update the minimum and simply return the mini and the maxi. But what if the odd length of array? So the last element is remaining. There is no any pair to compare this element. So explicitly we have to compare this 7 with the maxi and mini, and then update the maxi and the mini, and then finally you have to return the answer. And there is only one more edge cases, that if we have only one element, then we have to compare this one with the minimum and the maximum, and we have to update the minimum and the maximum. So this is the optimal way, that is pairwise approach to solve this problem. So now I'm going to write the pseudocode for this. Declare one answer array, which is used to store the answer of this problem. And if the size of the array is equal to 1, then we have to simply push that element as the maximum and the minimum. Now we are going to declare four variables. The first variable is maxi, another variable is mini. Now compare the first two elements, that is array 0 element and array first element. And if this element is lesser than array first element, then this one is the minimum, otherwise this one is the maximum. So we have found the maxi and the mini. Now we have two more variable, that is max element, maxi element, and the mini element. Now traverse for loop from index equal to 2 and run till n minus 1, and every time we have to update I by I plus 2 and find the maximum and the mini element. Like if array of I is less than array of I plus 1, then this one is mini element, otherwise this one is maxi element. Now we have to compare the maxi element with the maxi and mini element with the mini. So write the code for compare maxi with the maxi element and mini with the mini element. And there is one more edge case, like if the length of the array is not equal to even number of the length, if n percentage by 2 is not equal to 0, means it is odd number of length, then we have to compare the last element with the maxi and the mini. Then we have to return the maxi and the mini. So this is the optimal way to solve the problem. Let's talk about the time complexity of this problem. So your time complexity is big O of n, because we are using for loop. So it is using big O of n. Exactly it is n by 2, but n by 2 is also a big O of n time complexity. And we are not using any extra space. So the space complexity is big O of 1. Now implement this problem on the code editor. Let's jump into the code editor of the GFG and see how this problem will solve. So the first we have to declare the answer vector, and then we have to explicitly tackle the edge case when the number of element inside the array is 1. And after that we have to declare two variables, that is maximum and the minimum. And then we have to compare the first two element and find the maximum and the minimum. Then we have to declare two variable, that is maxi element and the mini element, and traverse the loop from I equal to 2 till n minus 2. And compare those maximum and minimum element with the maxi and mini. And if the array length is odd, then we have to explicitly tackle this problem also. And after successfully finding the maxi and mini, we have to simply store this value inside the answer and simply submit this code. So you can see that I have declared one answer vector that store the final answer, And for the edge cases, if array size is equal to 1, then we have to push the same element as the maximum and same element as the minimum. And we have to return the answer. And after that, we declare two variables, that is minimum and the maximum, and initialize maximum and minimum using first two element. We find the first two element, which one is maximum and which one is minimum. So I have written this logic, and after that I declare two more variable for comparing the pair, that one is a smaller element and the larger element. And our for loop is starting from I equal to 2 and run till I n minus 2. And every time we have to update I by I plus 2. If the array first is lesser than the array second, then the smaller element is this one and the larger element this one. So I have written this logic. You can check it. And after that, we have to compare this smaller element and larger element with the maximum and the minimum and found that maximum and minimum. If the length of the array is odd, then we have to find the last element and compare the last element with the minimum and compare the last element with the maximum and update the maximum and the minimum. And at last, we have to store the final answer inside the answer. So answer dot pushback minimum and the maximum. And then simply we have to return the answer. Let's compile this. Okay, all the test cases are successfully completed. Let's submit this. So this is the way you can solve the problem in the brute force way, better way, and the optimal way. If this breakdown is helpful for you, then please smash the like button and please subscribe to the channel. We will see you in the next tutorial. Keep coding. Thank you so much.